In our vectors window, we see the pin names oriented vertically across the top of the vector data. Blue vector data means expected output or response from the DUT, and amber data is input or DUT stimulus. Our vector addresses are in decimal, and on the right side of the window are the comments. These can be typed at any time by the user, and they're saved with the vector file. While in the vector window, we have access to certain tools for searching or manipulating vector data. We can fill vectors with a given pattern or copy vectors, and we can also generate vector patterns. Let's just type G into the D pins and pick a pattern that we would like to generate, say checkerboard. When we view these D pins, we now see the alternating ones and zeros that make up a checkerboard pattern. When we modify the vectors by typing in the vector window, we're really changing the content of the RAM in the tester for the vector data. Unless we upload the file, our original vector data is unchanged. All we have to do is to download the vector set again. Let's take a look at our vectors merged with the timing. By clicking the Extended tab and selecting Vector Graph, we can see a logic analyzer type of view. Our pins are oriented on the left side of the screen, with data moving horizontally to the right. Our clock pulse is quite apparent. We can see vector numbers along the bottom. At vector 0, our master reset goes low. Click anywhere and we can put a cursor on the screen. We can move this cursor to use it to compare edge placement. Certainly, vector editing and creation tools are important, even essential at times. But usually, your test vectors will come from a simulation file or perhaps from another tester platform. So let's take a look at High Level's CAE Link Translator.